All right, thank you for joining me on this episode of The Gospel Truth. I'm your host, Marlon Wilson, and we have another exciting show today. And yes, you guessed it, another debate. And this debate is piggybacking on the previous, well, not the previous debate. The previous debate was a Christmas pagan holiday, but the debate before that is piggybacking off of that one. And this one is there scientific evidence for a flat Earth? And if you watched the last debate, it was a lot. And before I bring the guys in, I do want to encourage you, if you can, to go ahead and like and follow and share this content. You can go to the Facebook page and like and follow there. And you can go to the YouTube page and subscribe over there. And both of those pages, make sure you cut those notification bells on. Also, all this content is on podcast. So if you're one of the person that's on the go, you don't have time to sit back and watch YouTube, go ahead and subscribe there. And hope you enjoy it. So, as always with the Gospel Truth, we are engaging the culture with Christian truth, and this is one of the subject matters that seems to catch some area of attention. And obviously, the flat Earth position is probably more on the what's the word I'm looking for? Not on the popular side of things, if you will. I guess it's the round. Jonathan, you still have to correct me. Is it round or for sphere Earth? We'll talk about that. Before y'all go to this debate, we're going to go into that a little bit. So I can make sure I get it right, man. But anyway, the flat Earth, you know, those who really truly believe and love Jesus Christ, believe what he did for the sins of this world, believe that he was the satisfaction of God's wrath against us, but they believe that it's a flat Earth. And that oh man, it's a tough one for me to swallow, and it's a tough one for a lot of people to swallow when it comes to the flat Earth idea. So, but we're gonna get into this a little bit. But before I do, let me go ahead and go over some of these upcoming shows real quick that I have coming up. All right. So after this debate, December 30th, the last show of this year, 2019, I have Travis Worth, and he'll be going up against Solomon Rodriguez, a Trinitarian versus Unitarian debate, and they're debating the nature of Jesus. The nature of Jesus and how should Hebrews 1:3 be interpreted. And then I have my first interview. All right, so the date just changed on this one. It'll actually be January 4th that Andrew Rappaport will be coming on. Something came up. I had to change the date. So we'll be talking to him January 4th and we'll be discussing systematic theology and his book, What Do We Believe? So I love Andrew Rappaport. I love his content. We're striving for Eternity Ministries, and him and Matt Slick have a live show that they do on a weekly basis. So I love those guys. I'm pretty excited for this interview. And then we got a Christopher Lee Christian, Joshua Dogal, and he's an atheist, and they'll be debating, do atheists have faith? So that should be a good one. That's coming up January 6th, 2020 at 6 p.m. Pacific Standard Time. And lastly, coming up January 27th, 2020, like I said, I just talked about Matt Slick and Andrew Rappaport. They have a ministry together, but Matt Slick is also coming on to debate Sonny Hernandez. If you don't know what Sonny Hernandez is, he is a part of the RAM ministry, Reform American Ministries, and he is a theological determinist, and Matt Slick is a compatibilist. So they're debating, does the Bible teach free will? If you don't understand the compatibilist position, compatibilist position believes that there is God's sovereign decree, but within that sovereign decree, human beings have free will within the natural state that they're in, whether it's for sin, or bondage to sin, or for righteousness. We have free will within those. And Sonny Hernandez, theological determinist, he rejects any and all forms of free will. So that should be an interesting debate, and that's coming up January 27th, 2020 at 6 p.m. Pacific Standard Time. So be on the lookout for all the shows. Once again, if you want to know all the other shows that are coming up, all this stuff is updated on my YouTube page and on the Facebook page. So be sure to go check all that stuff out. Be sure to put your eyes on that. And like I said before, click that like and subscribe. But with that said, I'm going to bring these guys in. Jonathan was on, like I said, for the Bible. Is there biblical evidence for let me correct myself. Is there biblical evidence for flat earth? So Jonathan was on a couple days ago for that debate. And all right, I'm going to destroy your name, dude. I'm going to destroy the name. So I'm going to call you just to respect, man. Mr. Pienaar. So I'm going to go there. Mr. Pienaar, I met Mr. Pienaar through a Facebook group. I think it's like the King James Version only is flat earth, something like that. I can't remember, but I met him through a Facebook group. Not saying that he's King James Version only, that's just one of the titles. But I met him through the group, and I put an invite out there for a debate. And him and Vernon jumped on it, and so Vernon was on last time, and now Mr. Pienaar coming on. So let me bring these guys in real quick. What's up, fellas? What's going on with you?
Morning.
All right. Early morning over here. Well, it's not early. It's early for me. I'm over on the West Coast. It's like 9 in the morning. It's 11. I think it's 11 in the morning over where Jonathan is. But it is almost 7 p.m. over where Mr. Pienaar is at, man. So drastic time change. South Africa's in the house. So thank you for joining me. I appreciate both of y'all. All right. Good morning. All right. So I was ready for a response, man, but it's all good. But yeah, so all right. So what we're gonna do? We're gonna go through this. Actually, I want you guys to give a quick introduction to yourself. So Mr. Pienaar, if you don't mind, you can go ahead and give a quick introduction.
If you don't mind, just want to thank people like P-Brain, Quantum Eraser, Rob Skiba, David Weiss, Eddie Bravo, most importantly, Eric DeBay. They brought me here. So, yeah, thanks for them. My name is Etienne Pienaar. I come from KwaZulu-Natal, small town Vryheid, heart of the Zulus, South Africa. I'm a general shop assistant at a fitting center. And yeah, I haven't been a flat earther all my life. Nobody has. So yeah, I wish everybody to have a listen and a look, and maybe they can learn something.
All right, thank you, appreciate you. All right, Jonathan, go ahead, a quick introduction for yourself.
All right, my name is Jonathan Walters. I'm a financial analyst by day, and my educational background is probably the most relevant to this debate, so I'll give a little bit of information on that. I took several years of math after my calculus series. Originally started studying to be an engineer for a while and then switched to a secondary education major with an emphasis in physics. Decided that the pay for the time to be a physics teacher was a little too light and got a business degree, and so ended up going a different direction. But have a pretty solid sciences background, so I'm looking forward to dusting off some of that stuff and bringing it to bear today. That'll be fun.
All right. Thank you so much. All right, fellas. So this is how we're gonna do it, man. The debate is there scientific evidence for a flat Earth? All right. So we're gonna start off with a 15-minute opening statement, and then we're gonna go into I think a 60-minute cross-examination portion, where both parties will get 3 10-minute opportunities to ask questions, and then we're going to a 10-minute closing. Sounds good?
Yep, absolutely.
All right.
Yeah.
All right. So you're going to be arguing the affirmative. I'm not going to destroy your name, bro. Mr. Pienaar, you're going to be arguing the affirmative on this one. So you're going to go for the opening for your first opening statement, 15 minutes.
Thanks. I would like to say, first of all, the ominous. As always, the flat earther has to provide proof. Yet, we never see a globalist or a person believing in a ball earth provide any proof themselves. They always jump to a cartoon image, an admitted cartoon image from NASA as their ultimate proof of their science. And we've all been brought up like that. We've been brought into think in this box that there is a universe, there's space, the ball earth, and aliens and all that. And I was there myself. But if you examine the properties of matter, the ball earth is a defiance of all laws of matter and the properties of it. They never provide you proof. They give you theories, mathematical theorem, but they don't use the scientific method. They don't use science at all. They jump to images and space images and cartoons from NASA as their ultimate prize. And we've all been brought up, it's authentic. It's authentic, but it's not authentic. You won't have people like Rick Simmons stating that Earth is Photoshop because it has to be. And he's the head graphic designer of NASA. So there's other graphic designers. Why would I need graphic designers if it's authenticated pictures? Everything we've been taught is a lie and defies the natural laws of matter, or observable laws of matter. That said, it's a hard concept to go and think out of the box that we've been taught into. We've been programmed to think that a mathematical equation is going to show you reality. And I can give you a mathematical equation where empty glass is equal to a full glass. It's mathematically sound, but that does not make it real. That's not a reality. It's obviously not the same. And that's what today's science is all about. It's a suicide, because they cannot demonstrate their science. They cannot demonstrate water on a ball spinning. They cannot demonstrate gas pressure next to a vacuum. They can only give you excuses and theorems, unproven. So it's actually just time to leave the fairy tale behind, and just accept the facts as it stands in science. I'm going to read what science is and what the scientific method is and what scientific factors, just to give people some more background on it. Scientific, or the science, first of all, is the field of study concerned with discovering and describing the world around us by observing and experimenting, showing the operation of general laws, properties of matter. The scientific method, as explained, is the problem is identified, relevant data are gathered, a hypothesis is formulated from these data, and the hypothesis is experimentally tested. Science fact. Facts learned by observation that has been repeatedly confirmed. So there's that. I don't know if I need more 15 minutes, but that's my standpoint.
All right, that's your opening statement right there. All right, Jonathan. All right, you got it for 15 minutes, Jonathan.
Okay, well, that was interesting. So the point of this debate was to present some positive evidence, and all we got there is no positive evidence. So let's start with some positive evidence. If we can go ahead and bring up that PowerPoint. I've got a few images that I'd like to discuss.
All right, Jonathan. Jonathan, do you want it full screen, or do you want you in the screen as well?
Yeah, go ahead. We can have it full screen for now, I guess.
Okay, hold on. Give me a second real quick. All right, I want to make sure that you're still on, because what do they do? It'll take you out, your volume anyway. All right, Jonathan, it's, let me restart it. All right?
All right.
You got it.
So for now, there's basically going to be three aspects of science that we're going to cover here, or three questions that we were supposed to cover. Unfortunately, none of that was covered during the previous opening statement, so I get to cover them again. This happened before, so that's all right. I got it. The motion of the Earth. So flat earthers will try to say that the motion of the Earth has never been detected. We might get into the Michelson-Morley experiment, but since we didn't get into that before, let's go ahead and skip over to slide 4. There are a couple of very simple demonstrations to address the motion of the Earth. So go ahead and skip the next couple slides. We might address that too far, back one. All right. So this image here is, what this is it's a long pendulum that is suspended from a pivot joint that allows the pendulum to swing freely in any direction. When it started swinging, over a period of time, it processes around in a full circle. Now, how much time that takes depends on where you are on Earth. In the equator, it doesn't proceed at all. At the North or South Pole, it would actually only take exactly 24 hours. In between those points, it takes a little more than 24 hours, depending again on exactly where you are. But as you can see, this will go through and it will gradually knock down all of these pins over a period of some amount of time, usually around 36 hours, again, depending on where exactly you're located. The only thing that would be causing this to move would be that the plane in which the pendulum is swinging is constant, but the ground underneath it is actually in motion. And so that's what causes the rotation apparent in the Foucault's pendulum. It's an excellent and very simple proof that there is motion in our world. Go ahead and move on to the next slide, please. And this is one of my favorite experiments done to prove the motion of the Earth. What you're looking at here is a gyroscope, an optical gyroscope that was purchased for $20,000 by flat earthers, given to a flat earther named Bob Nodell, who hooked it up and discovered that there is a 15 degree per hour drift. If you want to see this for yourself, there is a documentary on Netflix called Beyond the Globe, I believe it is. It's a very interesting documentary going into the flat earth movement, but essentially the flat earthers spent $20,000 and discovered that there is indeed a 15 degree per hour drift in the world that we live in, which would mean, of course, 15 degrees by 24 hours is a 360 degree turn, which means that the world we're living on rotates once every 24 hours. We use these things in airlines all the time to determine, you can actually set this up to determine the orientation of the airplane, and when it's landed, these gyroscopes can be used to actually detect where on Earth the plane is, just based on the rotation speed and that drift. So yes, we are in a rotating world. So let's go ahead and move on to the next slide. I love the experiments when flat earthers prove the globe. They do it all the time. It's beautiful. Now, so in talking about the curve of the Earth, one of the common things that you'll see flat earthers do is they will take some kind of picture and they'll say, I shouldn't be able to see that on a curved Earth. Where's the curve? Show me the curve. So go ahead and move on to the next slide there. What they're usually doing is they're using a drop formula of 8 inches per mile squared. This is a quick diagram. It's a little exaggerated, but to give you the idea of the difference between what a drop is versus what would be actually hidden from the eye. So a drop would be the distance from a line that is tangent to the surface of the Earth all the way down. And you can see there where we have the label drop there. That would be what would be measured by this 8 inches per mile squared formula. They will use this all the time, and then they'll say, see, you can still see this thing, but you shouldn't be able to see it. But what they're actually doing is they're misusing that formula. That's not what it's for. Go ahead and move on to the next slide. One of the most famous instances of this is the Bedford level experiments. Basically, somebody in the 1800s found this long stretch of river in England and decided to do some experiments. You can't really see it, but there is a bridge at the other end of that. He got in the water and aimed a telescope in the direction of that bridge and then had somebody row a boat all the way down to the bridge. When he could still see the boat at the end, or at least he claimed he could, he said, well, therefore it must be flat. Again, a combination of bad math, and then also there is some refraction, especially when you're over water. The density of the air over the cool water does change, and so that causes some refraction, and that was really not factored in. In a follow-up experiment, when challenged to prove that the Earth actually does curve, the experiment was devised that you can see in the figures below. A stick that is the same height as the bridge was placed in the water in between the two. The idea there is if it was flat, you should be able to look through the telescope and see the top of the stick directly in line with a point marked on the bridge. And if it's curved, the stick would actually rise up above the bridge through the observation. And so you can see in figures 1 and 2 there on the left what the expected results would be of the experiment, depending on what the shape of the Earth was. And then on the right, you can actually see an image of some sketches that were made by the referees of this test. This test was done with multiple observers. In fact, even the flat earther checked and said that those are accurate representations of what was seen through this telescope. It was an inverted telescope, but so you see the bridge and the stick upside down, but you can definitely see that the marker stick has risen above the level of the bridge, therefore proving that this is not nearly as flat as the flat earthers would like to claim that it is. There's actually a curve going on that raises the stick up above the line of sight there. It's observations and proofs like this which flat earthers frankly just prefer not to spend any time on, so that they continue the mantra of, you've never proven that there's any curvature. Go ahead and move on to the next slide. It's really convenient when somebody puts all the sticks in the water for you. There's a lake that actually has a series of power lines that when you take a picture of them, that's very obvious as to what's going on here. Again, if this was flat, we'd see a very different shape, but you see the rise and fall as this goes around the curve. Observations of curvature are easy to make if you're willing to actually consider what the reality of the situation is. Go ahead and move on to the next slide and we'll see another example. Flat Earth evidence. There's a meme on the left here, talks about a world beyond the imaginary curve. This is actually pulled directly off of Etienne's Facebook page. I appreciate him friending me so that I could get some of this. It was handy. And then on the right there, you can see an image which shows what would happen to that ship if the flat earther that was taking these images had just waited about 2 minutes for it to finish going over the horizon. You can see that the ships, while there is a certain point where you can see most of the ship, as it continues, you get to see where you can't really see it anymore. There's a reason for that. It's called curvature. It's there. You can take pictures of it. It's very easy to observe if you're willing to, again, open your eyes and not carefully filter information so that you only see the evidence that supports your position. Go ahead and move on to the next slide. We'll just take a little bit closer look at it. I wanted to blow this up so you can really see what's going on here. A flat earther might say, well, things just disappear from the bottom up because of some kind of optical illusion or distortion. And yet you can see on the ship on the far right, you can see the individual lines going from the towers. You can see the detail of the tower. It's all very clear, except the whole ship part is missing. There's a visual obstruction because of a physical curvature going on. This is no sort of optical illusion. Again, evidence for curvature is everywhere. All you have to do is open your eyes and look at it. Go ahead and move on to the next slide. And here's another one that it looks like this isn't actually running. This should be a GIF, but the tower that you're seeing there with the tower height of 15 feet, 1,815 feet there, a good portion of that, about 603 feet of that, is missing. If you see this GIF online, you'll actually see where they superimpose the actual image of the city, and you can see there's large portions of buildings missing. Again, the evidence of a curvature is everywhere if, again, you're only willing to open your eyes and look at it. It's definitely there. So much for the, well, we need to follow what our observations are. We need to do real science. Unfortunately, the flat earther isn't interested in real science. They're only interested in the science that fits their own position. Go ahead and move on to the next slide and continue. One of the things that we were going to talk about is space next to a vacuum. That was one thing that Etienne did mention during his opening statement. Flat earthers see space in this manner, where space is this gigantic vacuum cleaner that's going to be sucking all the atmosphere off of the Earth. However, that's not scientific. Space is literally nothing. There is nothing there. There is no stuff in space. And no stuff can't act on stuff. It cannot pull. Nothing cannot pull something. There is no force that is generated by the nothingness of space. This was actually proven in the 1600s. Let's go ahead and move on to the next slide, please. Torricelli's vacuum experiment was done in the 1600s. It was done by placing mercury in a tube and then essentially releasing it so that a vacuum was created. And the interesting part is, as you see in the last image there on the right, the globe on the spherical shape there at the top of the second volume. The reason for that is the amount of empty space. The question was, does the amount of empty space change the height of the mercury in the tube? If it was true that a vacuum actually sucks, or that it does something, it interacts with the mercury in the tube, then the larger empty space would have a greater effect than the smaller empty space. However, this experiment determines that it doesn't matter how large the empty space is, it's other factors that determine the height. And in fact, the height is going to be exactly the same on the mercury. This just proves that, again, vacuums don't do anything. It's just an absence of space. It does not exert any sort of force whatsoever. What is exerting the force that caused the mercury to stay in the tube is the pressure of the atmosphere on the mercury in the bowl below. And since that is equal, the height of the mercury in the tubes is equal, regardless of what is going on above that point. Move on to the next slide, please. Flat earthers will talk a lot about gas pressure inside of a container, and they'll even reference these formulas that talk about pressure, temperature, and volume. But there's something missing. There is no way to use these formulas to model anything that involves a changing pressure with regard to height. These are all for pressurized containers that you might have inside a lab, or like a propane tank or something like that. So they may be useful for calculating the pressure of air in a balloon when you heat it up or something like that, how the volume changes. But what it isn't going to do is it's not going to describe what's going on in our atmosphere, because there's no variance in height or altitude. Anyone who's driven from a sea level location to a mountain location with a water bottle or a bag of chips knows that there's something going on with the air pressure between those two locations. Move on to the next slide, please. This is a formula that is a little bit more complicated, but it deals with altitude above sea level and measures what the measurable pressure would be. And this has been experimentally demonstrated with weather balloons and various other methods that this formula is fairly accurate. The trend here is, as you see height along the bottom there, as height increases, then the pressure radically decreases below 10 kilometers. And then as you continue out to 50, it drops off to nearly zero, and ultimately to essentially zero as you get all the way out into outer space. There's nothing mysterious about this. This is simply how the atmosphere works. Unfortunately, since flat earthers do not understand how the atmosphere works, they simply choose to mock this idea and say that it is ridiculous. Let's move on to the next slide. The result of this is essentially this image to represent the reality of our atmosphere. You have probably never been above like the bottom line there, the line between the troposphere and the stratosphere. You've probably been in the vicinity of that line if you've ever flown on an airplane, but other than that, you've never been higher than this. And yet, even in an airplane, they have to provide breathing apparatus just in case there's loss of pressure, because you can't breathe even at that level, at least not very well. You would lose consciousness, in fact. So make sure you put the mask on yourself first and then help your child after, because your kid can't put the mask on you while you're passed out. If you can pass out at the top of the troposphere or the lower part of the stratosphere, the idea that there's this tremendous pressure up against the vacuum of space is just ridiculous. Again, that's just a failure to understand how the atmosphere actually works. So what is causing this difference in pressure and different heights? It's simply the tendency of gas, just like everything else on our planet, to fall down. Things fall down, guys. It's something that flat earthers struggle with, but really they do. Even air falls down. And so there's more air down than there is up. I don't know how to say that any simpler, but there's more air down than there is up because things fall down. It's really simple kind of idea. But essentially, the reason why the air isn't being sucked into space is because space is nothing. Space isn't doing anything, and space cannot pull against the tendency of the air to fall down. That's really all that's going on. Flat earthers will go on and on and on about this, but it's really so very simple. So we'll get to hopefully discuss this more during rebuttals and cross-examination. I really look forward to that. As far as if you can go ahead and move on to the next slide here, if I've got a little bit more time, I'll hit a couple other things. Just as far as some experimental evidence, how much time do I have? I feel like I'm getting near the end.
Yeah, you have about a minute left.
Got about a minute left. All right, so I'm not going to get into my supplemental materials. We will perhaps get into this as we go on. Flat earthers deny gravity despite the tremendous amount of evidence that it exists and so on and so forth. But I would just like to say that as far as the claims that flat earthers make that we just don't have any proof of our model is swimming in proof. The issue here really comes down to, first of all, being able to understand what's going on with the evidence. Do you understand the science of why the atmosphere does what it does and why curvature acts the way that it does and why you can see things that are a little bit far away? Or are you just kind of stuck in the information that you've seen off of YouTube and you are so attached to that you just won't hear what the other side of the argument is? And I feel like that's really what's going on here, and it's unfortunate. I hope I can reach some flat earthers through this discussion by showing them that there is the evidence that they're looking for, and that it's really their own unwillingness to see it that is the barrier that's causing them to believe what they believe.
All right, thank you so much for both of you for those opening statements. All right, now we're going to move into our 60-minute cross-examination portion of this debate. All right.
So we were doing rebuttals next.
Oh, okay. Yeah, that's right. Okay, rebuttals. All right, 10-4. All right, I think we said a 7-minute rebuttal. All right, yeah, 7-minute rebuttal. All right, so Mr. Pienaar, if you want to go ahead and give a 7-minute rebuttal to Jonathan's opening statement.
Yeah, he talked about pendulums, but a pendulum doesn't swing independently. You have to push it first. So there's no independence in respect to rotation. You can swing it at one side, you can swing it at the other side, you can just swing it in the middle. You don't see a pendulum swinging by itself. Hasn't been observed. Coming back to gyroscopes, Sagnet actually proved the ether. So the gyroscope is actually acting to the ether. It's not got nothing to do with the rotation of Earth. He was talking something about the Bedford level, but it's consistent with how water behaves and how you treat water. It needs to be contained, and once contained, it will seek level. If not contained, it will run down to the lowest point and seek level anyway. That's been observed. You are free moving, and you need pressure you need a container to have pressure on it. It goes all your university textbooks mentions a container to have gas pressure. Coming back to another thing is the Statue of Liberty can be seen from 60 miles away. That's been confirmed all over, and you can even Google it. The Statue of Liberty is 321 feet. But on 60 miles away, it should be underneath more than 2,000 feet. So there's that.
All right, Jonathan, you have 7 minutes to go ahead and rebut Mr. Pienaar's opening statement.
Very good. All right. So this is what usually happens when flat earthers engage actual evidence. What they do is they just rehash the talking points that they've learned online. The reason for this is because they don't actually have any scientific explanation themselves. It's a giant echo chamber where they just say, well, it's a container, gas pressure container. I don't know what else to say because that's all I've been trained to say. And it just sort of is this lockup mechanism of intellectual denial. So let's examine this a little bit. Etienne said that I was comparing gas pressure with mercury. Let's go back to the slide where I actually was supposedly doing that. That would be slide 15 in the PowerPoint there. While you're bringing that up, the point of that was literally to determine, does a vacuum exert a force on objects around it? It'll be the next slide after that. And so I was not comparing mercury to gas. What I was doing is I was showing experimental evidence to back up my claim that a vacuum doesn't suck. And everyone who's not a flat earther is like, of course, I know how a vacuum works. Because when a vacuum cleaner turns on, it lowers the pressure, and then the air outside pushes the dirt and everything into that space. But so when you have a low space next to, or if you have nothing next to a bunch of something, the bunch of something pushes into the nothing. But the vacuum itself does not exert any pressure or any kind of sucking forces on what's below it. The point of this experiment with the mercury is to show that vacuums do not suck. If the vacuum, if that emptiness exerted some sort of pull on what was below it, the larger amount of emptiness would exert a greater pull, and yet we see that it does not do that. That's the point of that experiment. Again, if you don't even understand the point of the experiment, you're going to have a hard time rebutting it. And that is where, again, doing your own research is much more than watching YouTube videos and repeating what they say. That's really important. Talking about the Statue of Liberty being able to be seen from 60 miles away, that we should have 2,000 feet hidden. Where's the math behind that? What is the observer height? Because that's kind of important. Again, if we go back to slide 7, where we were talking about calculating curvature, when you're looking at an object and you're trying to calculate how much of it should be hidden, it's more than just throwing in 8 inches per mile squared, which is that drop estimate. You'll notice that drop is a lot bigger than what's actually hidden there. And you know, I wouldn't be surprised at all if you were looking at the 60 miles, you were squaring that and saying there should be more than 2,000 feet hidden. You don't, you know, based on 8 inches per that amount, you should have all this amount hidden. If that's the formula that's being used there, which I suspect it is because that's the only formula flat earthers are comfortable with, then you're not getting the hidden height, you're getting the drop height, and that's a completely different thing. It also doesn't factor in the height of the observer for this. So again, I'd need to see the photo, need to know what height the observer was at. I bet he didn't lay his eyeball on the ground for this observation. So again, it's just a matter of not understanding and some poor math. And I wouldn't necessarily blame the flat earthers for this. Everybody's ignorant of something. Math isn't everybody's thing. But it's when you go online and you decide that you're going to become a subject matter expert on these things, as if you actually know what you're talking about, and then say that no one else in the world knows what they're talking about, and you are the master of all the sciences, and you figured out something that nobody else seems to understand, that where it just becomes a little bit ridiculous. If you don't know the math and you don't understand what you're calculating, then don't make claims. It's as simple as that. As far as the the water finding its own level with the Bedford level experiment. Again, the point of the stick over the water and everything, I would think, was completely missed in that. There's really the point of that is if you have a point that is some, whatever height it was, but let's say it was 8 feet above the water, and there's a point on the bridge marked 8 feet above the water, and you put an 8-foot marker halfway between the observation point and the bridge. If it's flat, the 8-foot marker and the bridge should line up visually, right? You should be able to see everything lining up perfectly. But if there's a curve in between, you're going to have the middle portion rise up above in the observation. That's the proof of the curvature that the Bedford level experiment shows us, or at least the follow-up to that experiment. The idea that, but the only response was that water finds its level. If you can bring up the very last slide, slide 22, I'd like to discuss this idea of water, or start with slide 21. I'd like to discuss the idea that water finds its level. Water curves all the time. The reason why water curves is because it is subject to the forces around it. If you've ever looked at water, you'll notice that it forms little spheres constantly. The reason it does this is because of the electromagnetic forces within the water. It makes that shape to minimize the energy in the system, just like all systems do. But water shapes itself according to whatever forces happen to be on it at the time. If it can curve like this due to an electromagnetic force, it can curve due to any force. Go ahead and go to the next slide here. The next slide was something that I pulled. It's got a lot of verbal explanation in there, but I'll just go through the visual part. If you look at point A and point B at the top here, this idea that water is always flat, the problem there is if you measure from the center of the Earth, A can simply get closer to the center of the Earth by moving across the picture over to B. The lines here I've placed kind of give you an idea that a line of the same distance pointing from A to B goes directly to the edge of this spherical shape. A is closer to this, is further away from the center of the Earth than point B is. And so A is going to flow to B until all of the water is as close to the center of the Earth as it can get. That's what down means. All
right, Jonathan, you have about 30 seconds.
Because of gravity. All right, 30 seconds. And so A and B will equalize so that they're the equal distance from the center of the Earth, which means, yes, there's even a curvature over large bodies of water on the globe. Again, this is basic science. And the lack of understanding of gravity and how water works doesn't mean that this isn't true. It just means that you really need to go back to school, dude.
All right. Thank you both for the rebuttal round. All right, now we're going to move into the fire. This is the big portion of the debate, the exciting portion, the back and forth. All right, so we'll have a 60-minute cross-examination. All right, both parties will have 3 10-minute opportunities to ask questions. All right, so we want to make sure that this portion is a dialogue and not a monologue. That was what the opening statement was for, is to have a monologue and to argue your point. We want to make sure that this portion is a dialogue where both parties are responding and questions are being asked to those, responding to this question that's being asked. So we want to make sure that the responses are a minute to 30 seconds, 30 seconds to a minute long, so we can make sure that the conversation will continue and not be stuck on one part of the conversation too long. All right, we got that? We got that, y'all?
Yeah. Absolutely.
All right, Mr. Pienaar, you have...
Still looking for the level.
No doubt, man. So, Mr. Pienaar, you have 10 minutes to go ahead and cross-examine Jonathan.
So far, actually, I just had an excuse from am I supposed to actually just ask him questions here?
Yes,
Can
that's
I-
the idea.
Yeah,
Ask
just
questions
just
about
asking questions. Yep.
what we talked about.
What is the properties of water?
What are the properties of water? Water is a fluid. It's slightly positively charged on one side, negatively charged on the other, which is why it tends to make those figure shapes and drops and so on. It, as a fluid, it tends to generally take the shape of whatever container you want to put it in, or obey whatever forces it is subjected to. It has very little resistance to any sort of force applied to it. I'm not quite sure where you're going with that. Flatness is not one of the properties, though.
As far as I know, is you need a container for any liquid, or for water specifically, you need a container. Okay. Water runs down to the lowest level, and once contained and still, it lies flat. You comparing a drop of water with surface tension. How can you justify a drop of water with a large body of water scientifically observed that, and the scientifically observation is a repeatable test. How can you justify surface tension with a drop of water to show curve, whereas the natural large bodies of water lies flat when contained?
Okay, so yeah, that's a good question, and I think you've misunderstood the point with the drop of water. The point of the drop of water is just to demonstrate. Let me go back and try that again. So the point of the water droplet is just to point out that water is not naturally flat. It will respond to whatever forces are applied to it. So whether that is electromagnetic forces or gravitational forces, if you push on water, it will move. That's the point. It doesn't have any resistance to whatever forces are applied to it. So when you pour it into a container, it takes the shape of that container. When you apply some sort of other type of force to it, then it responds to that force. So when it responds to the gravitational forces on our Earth, gravity causes the water to take a shape that minimizes the amount of potential energy involved in that water. So like that image that I showed, where A could flow to B, if it was flat, the water is going to naturally flow in that direction, like flowing downhill. If it can lower its gravitational potential, it's going to do that. It's going to flow in that direction, just like pouring water out of a pitcher or something. It's going to go as close to the center of the Earth as it can. So I'm not sure if that makes sense to answer your question, but we can review that image if that would be helpful. But I'll let you go ahead and follow up. Or was that?
Yes, I was, but it does not fully explain the observation, natural occurrence. But I'm gonna move to something else, the Bolivian salt flats, because you don't believe the water can lie flat. The Bolivian salt flats are 62 miles long. It's square miles. You should see 781 meters of drop, and this is according to topography data from Kinetic GPS. So there we can't argue from where it comes from. This is topography. So how can you see 62 miles then, or how can 62 miles be flat on your bull model?
Okay, so let's again just. I'm sorry, am I coming through okay?
It still sounds a little choppy. Still sounds a little choppy. So what I'm gonna do? I'm allow Mr. Pienaar to ask his question, and then I'm gonna mute his mic while you respond, so that we won't get that feedback. All right.
Yeah, I will. That's fine. Yes.
Okay. All right. So go ahead, Jonathan. Go
I
ahead and
think
respond.
do that on both sides. Yeah.
Yeah, I'll do it here, so you don't have to keep. I'll do it here, so you don't have to keep doing it.
Great stuff.
All right, Jonathan, you got it, man.
All right. So the question was, how is it that we can see a certain distance on on salt flats or literally any, supposedly flat surface on our globe? Really the reason is, I think you're not. You didn't give me any real data to work with there. See it from where? So what's your observer height? I'm assuming it's at least 5 to 6 feet, because most people are 5 to 6 feet tall, looking out across a area that's reasonably flat as far as we define flatness. But again, like, why would we be able to see that distance? Because again, if you're looking at some 60 some feet of drop, how did you calculate that? And again, what is drop? And that's something that I would really like to get into as I ask you questions. But I think what you're doing is you're looking at drop and you're saying, I shouldn't be able to see that far. And that's not what drop is. And so I think the reason why you can see farther than the drop is because you're not laying your eyeball on the ground to make that observation, and because you don't understand the math of what the drop means and what an actual amount hidden would mean. So again, it's just bad math, really.
Can I go now?
Yep.
This is seen from the top. This is GPS. This is topography data seen from the top, and it's flat. So I don't see where you're going with why we can't see the drop, because it's factual. There is no drop. There is no curve. It's flat. It's observably flat. It's got mirror images of clouds that you can only get on a flat surface.
I would just, I guess my response to that is GPS stands for Global Positioning Satellite, which at least 2 of those 3 words you don't even believe exist, and yet you're using GPS to argue your point, which I think is rich. But I mean, again, I'll just point out, like, you're saying that the mirage effect in the salt flats is can only be seen on something that's perfectly flat. And what's your evidence for that? Why couldn't there be a curvature that is like everywhere else on Earth is just too gradual for you to observe without some kind of aid or getting a different perspective, like in the images that I provided that do provide that perspective? Again, like, you're issuing challenges to things that you don't understand by pointing out that you don't understand them, and that just isn't really how science works. There is no reason why. I know that the word has flat, like salt flats has the word flat in it, but that does not mean that it is perfectly flat. It is still located on the globe, and so far you haven't presented me with a challenge that would necessitate some kind of absolute flatness.
All right. I'm just coming back to science fact, because I don't think you heard it correctly. Facts learned by observation that has been repeatedly confirmed. Where's curve repeatedly confirmed or observed?
Well, I provided several images that and several evidences in my statement that showed where curvature is observed. The problem I think that you have is you're looking at starting from a bad mathematical formula. You are trying to say anything that doesn't fit my bad math therefore proves that the Earth is flat. But it just proves that your math is wrong. It doesn't prove that there is no curvature. It just proves that you don't understand the curvature, and you can definitely see images of it. I showed those images in my opening statement. I'd be happy to bring them up if you'd like to review them.
Yeah, well, that's why I'm gonna ask you this. If you're just standing and you're looking straight, you're standing your normal height and you're standing straight, let's say straight ahead of you where the horizon is about 3.5 miles, 4 miles, I'll give you that. But from left to right, you see more than 3 miles. You see like, wow, 100 miles. Why don't we observe? Because it's a horizon line. We don't see that curve there on the horizon line. But you can see curve on 3 mile stretch ahead of you. I don't think you understand your curvature method.
No, I understand it. It's the Earth is big. I mean, the reason why you see the horizon going in in this great big circle around you is you look to either side, and it might look like a level line, is because Earth is very, very, very large. And the thing is, as far as why can you see it curving in this direction, it's usually quite a distance before you see that. But again, you definitely can observe those things. I've shown you those photos. And if you get higher up, you can see further, which doesn't make any sense on a flat Earth. So again, the observations are still there, and you're not understanding them doesn't constitute their disappearance.
All right, that's 10 minutes. All right, Jonathan, you now have 10 minutes to cross-examine Ms. Pienaar.
Excellent. So I'd like to pull up slide 8 because I want to ask Mr. Pienaar about about some of the observations being made there. So this is about the Bedford level, and while we're bringing that up, I'd just like for you to explain to me what you think it means that this observation marker placed in between the bridge and the observer at the same height as the observer and it's the same height of the bridge appeared visually to be higher than the observer and the bridge in the center there.
Sorry, can I come in?
Oh yeah.
You must remember, we've got limits to our eyes. We only see on a certain degree. Everything will move to a horizon point the further you go away from it. It doesn't mean it's curving. I can have a 100-mile stretch, flat surface. Starting from there, I can have a big ball up in the sky. The further I go away from that observation or that big ball, the lower it will drop to a horizon. There's limits. There's limits to perspective, and that's why horizon always. That's why everything. The further you go away from something, will always drop to a horizon line. But obviously, there's atmospheric interferences there. There could be heat. There could be mist. There could be a lot of things that gives your perspective, because your eyes are limited. It's 1.2 something.
Okay, so what I would, again, I feel like what you did there is you sort of spun off into some talking points about perspective that really don't apply in this situation, because what's going on here is in the telescope, they were able to see the bridge on the other side with sufficient clarity to identify the marker that they placed on the bridge. And they were able to see the stick in the middle with sufficient clarity to identify the markers they placed on that stick. And so there's not really enough visual distortion. And if that distortion was there, we wouldn't be able to see the bridge. Like, it doesn't make sense that this is some kind of visual distortion here. I know that that's what YouTube has trained you to say, but I want you to apply in this particular situation. Why is the stick higher than the bridge? Because everything that you just said is a bunch of word salad and none of it applies to the situation. So I want to give you another chance to answer.
That's why I can't see to China. You can't even see the end of a long hallway, but you expect to see the end of China or to see to China, but you can't even see to the end of the hallway. The horizon will always go to eye level. After that, there will be distortion, atmospheric distortions. That's it. That's why when you rise, the higher you rise, the higher the horizon will come up to you. You can't have that on a ball model. It's impossible.
Okay.
And it's observed.
So what we had there is an attempt to answer, and again, you didn't really respond to my question. You just fired off a whole bunch of flat Earth talking points. So I think what I'd like to do is move on to the next slide and ask you again with a slightly different point of view here. Can you explain what's going on here with the power lines that are all, these are all manufactured, all the exact same height, and yet we see them rising over as they get further away, we see them rising up. Can you explain why we see them rising up over what appears to be a curve here?
Yeah, well, it's still an atmospheric disturbance, but let's have a look here. From left to right, you still have a horizontal line. All right, that's further than the line where it's supposed to be curved in front of you. So why don't we observe those curves? Why don't we observe from left to right a curve? If there's a curve, how can you have two straight lines and then have a curve? You've got a straight line in front of you, and from left to right, you've got a straight line. So you're telling me you're curving over a straight line. And those poles are exactly the same height. It's not like they put curvature onto otherwise it would have been made shorter or something else like that. But that doesn't happen. There's other photos on the other side that shows a straight line. You can't have two straight lines and a curve. You can't measure curve on two straight lines.
All right. So again, I feel like the only thing you're saying is about the horizon in the distance being flat, but you're not really explaining why we see this uphill curve around the power lines there. So I feel like I'm not getting an answer. So let's move on to slide 11. Yeah, talk to me about the ship on the right here. Where is it?
If you can observe so much curvature there, how big is your Earth? All right, let's continue. Sorry.
So it's about 9.9 nautical miles away. I just want to know where the rest of the ship is, man.
What about it? If I have a if I have a P1000, I'm going to zoom into the last ship. That doesn't mean anything, and it's still a straight horizon, sea level, in front of you, left to right, and in front of you. So you're still presuming curve on straight lines.
Okay, I'm gonna challenge you and ask you again about you claim that you can zoom in on that, but you can already see you can see the lines in the ship, like the cables. You can see details on the cabin, but you can't see anything on the base of that ship. You're as zoomed in. It doesn't matter how much you zoom in on that image. It's not going to get any clearer. It's not going to come into view. You're already zoomed in on this image, and it's gone. Like there's no bottom of the ship there.
That's the law of perspective. Obviously, you can only see so far. People don't realize their eyes can only see so far. How far can you see underwater? How far can you see underwater? Or can you see for miles and miles underwater? That's the same thing.
So I would again ask, because I can see this, right? This isn't I can only see so far situation. I can see it just fine. I can see the cabin. I can even see the cables on the ship. I can see everything that is within my visual range just fine. But then there's something blocking my visual range. I want you to tell me what that is.
Disturbance is heat. It could be anything. It could be vapor going up, heat, anything, dust. anything can go in front there. I mean, there's space in between. There's something going to move in front of it. You can only see so far. That's why you can only see so far underwater. It's the same principles.
All right. I feel like you're not answering. All right, let me ask you in a different way. Why can I see the cabling on the ship? You said I can only see so far, and it's past where I can see. So why can I see the cabling?
Why can't I see to China?
Why can I see the cabling?
When the conditions were right. Okay, when the conditions are right, you can see great far distances. But when the conditions aren't right, you can't. That's just the conditions of the atmosphere. That's all. But your perspective will always be going to a point on the horizon. It will lift up. If you go if you stand in a long hallway, what do you see? At the end of the day, you see a small dot at the horizon because it's going to meet your eye level. Your eyes don't go from seeing that and going outside and being different.
All right. I think we've killed this idea. I'm not going to respond right now.
41 seconds, Jonathan. Yeah, about 40 seconds.
I have questions, so I'm going to leave it at that. I think I've asked everything I can about that. I'm not going to get an answer, so we're good.
All right, Mr. Pienaar, you have 10 more minutes to go ahead and cross-examine Jonathan.
Cross-examine or ask him questions?
Yeah, that's it. That's cross-examine is to ask him questions and he'll respond.
I'm going to come back to gas pressure. And I'm going to read from techtarget.com. Because I still think you're outside of a container and we haven't actually discussed that. You still think we're in an outside world where there's universes. But what they say about gas and their behavior, let's have a look at this. And then I just want you to explain once again how you defy the laws of this behavior, this observable scientific behavior, and your ball earth is an open system. Let's just go over that again. What they say is a gas is a sample of matter that conforms to the shape of a container in which it is held and acquire a uniform density inside the container, even in the presence of gravity and regardless of the amount of substance in the container. If not confined to a container, gaseous matter, also known as vapor, will disperse into space. That's observable. We've proven it. It's in the scientific method. We haven't observed gas pressure next to a vacuum without a barrier container. Can you please explain why your ball earth defies this?
All right. So, yeah, I'd be happy to clear up your misunderstanding on that. So when what you're reading is for gases that are in some sort of container, which we have gases in containers. We've got propane tanks, we've got balloons, we've got all kinds of ways of containing gases under pressure. And when you have a container that fits in a laboratory building and you put it under pressure, it is going to have a uniform density within that container. That nobody is disputing that. The issue is when you go out into the great outdoors, which is a lot larger than your laboratory, and you climb a mountain, when you get to the top of that mountain, you'll find it's a little bit harder to breathe up there. That if you take a bag of chips with you from sea level up into the mountains of wherever mountains you have in your area. I've got Colorado near me, the Rocky Mountains, beautiful area. You drive up there from where I live, and you take some kind of either a water bottle or a sealed container of some kind, and you go to open it. It releases some sort of pressure because there's a difference in pressure from even up in the mountains to down where you are near sea level. So the trying to use a small laboratory contained container model for the outside where we do see differences in pressure depending on where we are doesn't work. It's not a valid model. You need a better model for that different situation.
Are you talking about gas pressure gradient?
Yes, the pressure outside changes depending on how high you are. I don't know. I mean, I hope you acknowledge that.
You still haven't told me where you got the gas pressure or what contained it.
I guess I'd like to refer you back to slide 17, where we have a mathematical formula that explains how gas pressure works dependent on altitude, which is a much better model than the one you are reading from. You're reading from a textbook type definition of a small thing contained in a lab room somewhere. That set of rules works very well for that circumstance. You cannot apply that circumstance to outside. They're different circumstances and they require different models.
Pressure naturally.
I think because of the echo,
You already demonstrated the mercury thing, so that's a natural thing. And that's in a container.
What was your question? I'm sorry, I missed it.
In order to have gas pressure, you need a container. Even with the mercury thingy slideshow you had there, you need a container. The molecule, you can only have gas pressure when the molecules goes into a container. All your university textbooks says that. It needs to bounce off something. It doesn't bounce on a ball. There's no container on a ball earth.
All right, so let me try to clear up a misconception you have. The idea that you have to have a container for gas pressure is something that you're taking out of context from those textbooks you're reading. What those are describing is the container being something in a laboratory where you have a pressure that is greater than the pressure of the air around it. If you were to take a measurement of air pressure just standing outside, you would get some sort of reading. If you attach that measurement device to a weather balloon and send it up into the sky, that reading is going to change according to the formula for measured pressure change in altitude, that is the barometric equation. So again, we have a measured pressure difference from one place to another place outside, and that doesn't fit the physics of gas inside of a pressurized container either. And so you've got a problem there. You keep saying container, 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 but what we observe does not match the physics of gas inside of a pressurized container.
Yeah, but that's because we're not living in a static system. There's a dynamic system. There's carbon, there's hydrogen cycles going on there, and the heat is not constant. Okay, there's no ideal gaseous precious state anyway. But what they do say here in another university textbook is, does the diffusion of solid particles takes place down the concentrate gradient? Pressure gradient with respect to partial pressure of gases until uniform concentration is achieved. But what you're saying now is you want to justify 760 torr sea level gas pressure and say it maintains its state against 10 to the minus 17 torque. That's 760 parts in 1 against 1 part in 100 quadrillion. And 100 quadrillion seconds is 31,000 years. So that's just the idea of how large it is. Heat goes into cold. That's how energy behaves. Energy is concentrated and dispersed. High gas pressure to low gas pressure. That's it. I can't pump up my wheels on my car if there's no tire. Because that's what you say. You don't need a tire.
Okay, man. So I'm going to respond to that because there wasn't a question, but I'm going to respond there. So this is a typical flat Earth argument, right? We've got this tire pressure with no tire because obviously there's this extremely high pressure right next to no pressure, and they completely forget about the like 90% of the atmosphere that's between sea level and space. They want to put sea level and space right next to each other, man. You can't put sea level and space right next to each other. They're not next to each other. There's a huge difference between the two. And I would like you to at least acknowledge that.
But there's still pressure. You still haven't got past where you got pressure from.
Of course I have. I've
because it needs a container. And your ball earth doesn't have this container. It's open.
The physics of gas
sure, if you know your ball earth.
All right, so the physics of gas in a container does not apply to outside. It doesn't even work on the observations you can make yourself. Drive up a mountain. Physics in a container doesn't work, even for that. So stop trying to apply.
What's observable and testable except a NASA photo of a Photoshop photo of Earth? So once again, we'll come back to science. All right, science fact.
That's 10 minutes right there. That's 10 minutes right there. All right, so okay. Jonathan, you have 10 more minutes to go ahead and cross-examine Mr. Pienaar.
All right, very good. So yeah, I really am looking forward to this, to really getting into this exchange because as we've seen, there's a big difference. So let me. Can we pull up slide 16? I would like to ask a question about slide 16 here. All right, so what we have here is a number of different gas laws. Is there anything within these gas laws that would explain why when you drive up a mountain, your ears pop, or why the atmospheric pressure essentially gets thinner as it goes higher up?
They mentioned P a lot. So that's pressure. So you need a container.
That's right. For all of these formulas, they're all describing gas inside of a container. That is correct. So do you believe, let me go back to the basics. Do you believe the air actually gets thinner when you go up?
Yeah, well, you can't breathe on top of Mount Everest or something like that. It's obvious, but it's always going to seek equilibrium because of the cycles, because of carbon and hydrogen cycles and heat changes. It will change, but so you have to observe it in the container. That's an observable fact.
So if you wait on top of Mount Everest, will you be able to breathe at some future point? I mean, it's pretty consistent that the air up there is pretty thin.
Yes, exactly. But it's still seeking equilibrium. It's still at a regular equilibrium state.
What do you mean by equilibrium?
You still need a container to have it. Otherwise, it would disperse like I went through on your university textbooks. If not confined to a container, it will disperse into space.
Right. Again, there's a context to that. And so I would like to just ask again, without you going into those talking points, please just explain to me what you mean by equilibrium very quickly. You've used that word several times.
It's going to seek equilibrium, but it's not going to find it
What
because
is
of
equilibrium?
the amount of substance.
What is equilibrium?
Of that, you still need a container. Otherwise, it will disperse. It's just, you can't prove gas pressure next to a vacuum, or it's not as, like you said, it's not sucking. I'm not saying it's sucking, but you can't prove it either. If I take away that barrier, the high energy is going to go into a low energy. That's just normal logic.
Okay, so if high energy goes to low energy, what makes you think that flying off into space is lower energy than staying down?
Sorry, come again. You mentioned something, space.
Okay, so yes, so you're talking about high energy and low energy. I want you to explain to me why you think flying off into space represents low energy, whereas falling to Earth represents high energy, because that seems to be the assumption you've made.
You've made the assumption that there is space, but we haven't even got out of the container yet.
Okay, again, we're discussing the globe model. Whether you believe it's true or not, there is space in that model. And so you're saying in that model, if it were true, which, again, to criticize it, we need to at least hold to it, right, for just a moment. I need you to, no one can hear you, so just don't even bother. Why is it in the globe model, going off into space is low energy and falling to the Earth is high energy?
Because there's more molecules. It's bouncing around. There's energy here. There's energy in our atmosphere. That's was logic. There's nothing. You said there is nothing. There's no energy in space. So I don't know. You wanted space, but you can't prove it because we haven't gone out of the container yet.
As this pen seeks low energy naturally, which way is it going to go?
It's potential energy because you are holding it.
Yes, and when I let go, what is it going to do?
And then you can make up the mass of where it can go. But we can't say it's going to go there. We can't say it's going to go there because it's free moving. Gas molecules are free moving fastly. It's going everywhere all the time. Now you wanna hold a pencil or a pen and telling me that's the same thing.
No,
sorry.
Let me clarify and ask the question again. So when I'm saying something's going to low energy, a lower potential energy would be to be as close to the surface of Earth as possible. So all of that gas wants to fall down. And then you're right, there's a lot of gas down here, and so it gets knocked back up, and there's a lot of dynamic systems going on. But you're saying, how do we have the pressure? And I feel like you're not taking gravity into effect. Is that true?
Yes, because it's stated here, regardless, even in the presence of gravity and regardless of the amount of stuff, even in the presence, it says there, even in the presence of gravity. So yeah, I'm not sure why you want to contradict scientific textbooks here.
I'm using it in context.
So you make your own stuff now.
All right, so I'm gonna move on. I'm using it in context. So let's go ahead and move on to the next slide because I think we've gotten a little off track. Let's look at slide 17 real quick. So here we've got a mathematical model that involves both the pressure and the gravitational attraction of the Earth, which we know things fall down. And we see that based on this model, we would expect that when height h is low, which is going to be toward the origin of this graph, you're going to have pressure P high. And then it's going to drop as height increases. Now, we can see this by going up a mountain. So what I would like to ask there is what happens, according to this model, when we get very high? What happens?
First of all, I want you to demonstrate it next to a vacuum. And if you're going to tell me you can't demonstrate it because we need a ball earth, then it becomes a mathematical belief and not demonstratable, and then it's not scientific because we don't observe this, we don't experiment it.
Yes, we do. We have weather balloons, we have aircraft, we have all kinds of things that demonstrate that this is actual fact. The same textbooks that you're quoting to me about gas pressure inside of a container also teach the barometric equations. They're equally true, they're just for different situations.
I'm still going to ask you to demonstrate me gas pressure next to a vacuum.
Because
even partial. You don't even have to have a lot of gas pressure. You can even just have a little partial. You can just boop, and show it to me from next to a vacuum without a barrier container. Because what you're saying is what we see at sea level, 70, 60 tall sea level, against 10 to the minus 17 tall. So you actually saying to me, we need to experience, or we are experiencing 10 to the minus 17 tall.
All right, so let's go to slide 18, because now I would like to point out, Etienne, it is not your turn to ask questions. You're supposed to be answering questions, not ignoring my questions and then asking me the same question over and over. But so here's what we're going to do. I'm going to ask you very quickly. So please don't monologue. Please don't throw me a whole bunch of talking points off YouTube.
Hey,
just
Jonathan,
answer
you have
me.
about 1 minute left.
All right. Answer me very quickly, within 10 seconds. Where is the high pressure that you're talking about in this little graph here?
It doesn't need to be high pressure. It says,
okay,
regardless of the amount of substance in the container, if not contained to not confined to a container, gaseous matter, also known as vapor, will disperse into. So it doesn't matter.
All right.
Matter how much force there is. It doesn't matter. I can, like you demonstrated with that heavy gas in a container, in a classroom in a container. But I'll tell you that if you walk away for 3 hours, that heavy gas will disperse. That's just a fact because it's not contained.
I only have somewhat. I have very limited.
Floating around in air, but it's not going to prove anything because it's not even next to a vacuum.
All right, that's
it will disperse. They explicitly say this.
Okay, that's
it doesn't. It doesn't matter. How do you get PSI?
All right, that's time. That's time right there. All right, Ms. Pienaar, you have about 10. You have 10 minutes to go ahead. Your final 10 minutes to cross-examine Jonathan.
Examine him. Actually, I just want to ask him a few questions here. If you don't mind, Jonathan, I won't cross-examine you further because we chatted back and forth. So I cross-examined you while you answered me. So, or while you questioned me. So I just feel it's unfair to cross-examine you further.
Oh, no, it's great. Please do. In fact, don't do anything but cross-examine me further because that's what this portion of the debate is for. So you ask questions, I answer them.
Yeah. No, you already couldn't answer them, actually, so.
I answered them just fine. Keep asking. Let the audience decide who can and can't answer. So just keep asking the questions. That's what this is for.
I just actually want to go to somewhere else where I had my information. Sorry, I haven't studied like you. I'm just going according to your textbooks and stuff. So, come on. Yes, I want to ask you this question because we're going to go to now rotation, if you don't mind.
Great.
According to your rotation theory, I would see it as when a plane flies from east to west, it would take less amount of time because the Earth is running up to it. It's moving eastwards while going eastwards. Okay. But if you look at flight times, say from Charlotte, Carolina, to Los Angeles, and you take the speed times and the rotation in equation, it will take you 1.5 or 1.5 hours to reach the destination. But in actual fact, it takes 4.5 hours. How is that?
Sure. So why is it that it doesn't take any longer to walk to the lavatory in the airplane than to return to your seat? Because you're moving, it's the same speed as the airplane is, and you're just walking along inside of the airplane. So when as the Earth is moving, the airplane is moving with it, and then it's moving relative to the Earth at a certain speed, going one way or the other really doesn't matter, because the whole Earth is moving and everything around it is also moving in that same way. And so what you're doing here is you're mixing up the fact that, well, see, the plane is going 500 miles per hour in this direction, and so if you're walking back to your seat, it should take a lot longer, right? Like the plane is going this way, as you're walking back to your seat, it should take a lot longer than when you're going back to the lavatory in the back, because the lavatory is coming at you. That doesn't make any sense because you're on the airplane and everything is in that system is moving. So again, like this is just a matter of you not understanding a closed system and how it works.
Oh, did you say closed system? Did you just measure closed system?
It's not closed in a literal box, but it is a system.
Did you just measure system?
It's amazing to me that that is the only word you said.
What I was going to ask you is let's just leave the cloth. Let's just open up the aeroplane, and it's obviously going to do that, isn't it?
And when we open up the airplane,
it's just saying it needs to be closed to do that.
There's something outside the airplane interacting with it.
You're comparing a bee in a car while it's closed and it can move freely. But when we put down those windows, that bee is not going to move freely, is it?
Because there's something outside the car. The convenient thing about space being empty is that there's nothing outside, so the windows can be open and it doesn't affect anything. So nice try, but your model fails.
So you're already saying you've got a closed system to prove your rotating open system.
No.
That's
you misunderstood
quite interesting. Quite interesting.
You've only heard one thing that I've said this whole debate, and you misunderstood that one thing. So quite frankly, you shouldn't harp on that point too much. It's closed by gravity in an atmosphere, not by a glass dome. Which you have never
it can't be closed by gravity because we already discussed what your system says regardless of gravity.
You don't understand those words. You don't understand the context of the words.
So which gravity are you referring to now? Because that was the actual, that's always the gravity thing. So I mean, you said you're not even going to have gravity, but you're assuming a center of a ball that you haven't even proven yet. We've dug like what 15 kilometers down on the Earth, and you're assuming what is lying down beneath that. That's a fallacious assumption.
All right.
To prove a ball, I have to assume a ball.
I forgot how to ask questions again. So as far as I'm assuming a ball we haven't proven yet. The fact that you reject all proof does not mean that the proof does not exist. And your job in this debate has been to provide some sort of positive evidence of your model, which all you've done is laugh at my model without proving anything. And so what the response to your mockery there is simply that the proof is there. You just haven't bothered to actually pay any attention to it.
Okay. Whatever you say, but still, if the Earth is rotating, you have to have an independent atmosphere. And every freely moving object in it, that's planes, balloons, bullets. All right. So I'm still coming back to why does it take 4 hours instead of 1 hour, according to your mathematical equation of a rotation Earth plus the plane flying? Because you now said it's a closed system.
So you seem to be thinking when the airplane is sitting on the runway, it's not moving, and then as soon as it takes off, it when it's sitting on the runway, it's moving at the rotational speed of the Earth, and then when it takes off, somehow it just suddenly completely stops moving, and the Earth rotates around it. That's ridiculous. It's still moving that relative motion, that motion that had of the rotation of the Earth, is constant until it accelerates in a particular direction. So it takes off and it starts accelerating in a particular direction. But all of that rotational motion, all of that motion that it was going before, is still going that direction. So again, you just don't understand motion. And your assumptions that you're making in this question just prove that you desperately need to take a basic physics class.
Fine, that's what you just said. So now what is keeping the plane from it?
Keeping the plane from
because
what?
The atmosphere is independent of the Earth spinning.
No, it's not. No.
Then you can't have a Coriolis effect.
You think the atmosphere is slow?
If that is not true, then still you'll be. How can you fly out of spin and not fly out of spin?
It's all spinning. The atmosphere isn't staying static. Well, the atmosphere is all moving. The whole thing is moving. I don't understand what you think is going on, but it's not nearly as hard as you're trying to make it.
This is a simple analogy. Okay, I'm on a merry-go-round thingy in the park. I'm spinning. 2 people outside it is throwing a ball. Independent of the spin, the spin is not affecting it, but it's going to appear to be curved. That's the parent effect, because you think you are spinning already, but it's not. The ball is still going in a straight line while they're passing it. You see it as going in the curved line, but it's independent. Like you said, it has to be independent, and all your textbooks say it.
I want to answer the
all right, Jonathan. I'll let you respond to this last question, and then that'll be time for Mr. Pienaar.
All right, so let's examine that model of the people throwing a ball off of the merry-go-round. Somehow you seem to think that when the airplane takes off from the Earth, it has left Earth. Like it is left, it's no longer part of the merry-go-round system. It's completely outside of it. And that's just not the case. Your analogy is more like if you're on the merry-go-round and the merry-go-round is going around once every day and you're standing on that merry-go-round and you're throwing a ball back and forth to each other, why doesn't the ball go faster one direction than the other? That's the model you're actually dealing with, and hopefully that answer would be obvious to most people. Yeah, that's pretty much all I have to say on that one. Your entire model is busted, dude.
All right.
Okay, and then
right.
now I'm gonna say you've got a small scale model because it's not going. We're not talking about a 2-meter merry-go-round. We're not talking about a 2-meter merry-go-round.
All right, that's time right there.
Spinning 24 hours to make 24 hours. We're talking
Please
about
be respectful.
All right,
Be respectful of the time, please.
That's time right there.
Isn't
All right.
it?
So we're gonna conclude that one, that portion right there. All right, Jonathan, you have 10 more minutes your final 10 minutes to cross-examine Mr. Pienaar.
Okay. Yeah. So tell me about the 15 degree per hour drift. Bob Nodell, flat earther like yourself, investigating, doing science like you said, found a 15 degree per hour drift, which equals 1 rotation every 24 hours, which is exactly what the globe model would expect. I'd like you to explain what's going on there.
Okay. The gyroscope model was based on Sagnet. Sagnet's experiments proved the ether. Okay. It proved the ether moving. It proved the ether has an effect. So the gyroscope is probably just going to pick up the ether. It's nothing to do. It's nothing to do with rotation.
Okay, so was that Sagnac's conclusion that he proved the ether? Or is that just something that you're reading into the experiment?
And I've got something to say about it, or what the scientific community had to say about Sagnet's. If you want to hear it, I can tell you what they said about it, because they don't want to leave that Einstein theory alone. So when he made the experiment, the observation, the natural observation that's scientific, all right, he did an experiment, and what they concluded is this: the rotation is rotation with respect to an inertial reference frame. Since the experiment does not involve a relativistic velocity, the same wording is valid, both in the context of classical electrodynamics and special relativity. Sagnet's experiment clearly proves ether, but what does Einstein prove? Where's his experiment?
Who are you quoting right now?
I don't need to quote it. This is from the time. Well, it was established there. That's what I say in reference to it. That's what the scientific reference to Sagnet's experiment is.
No. You can't just say it's the science people. Tell me who said that, please. If you're going to quote something, please.
I'll give you some links now. It's a wiki, actually.
A wiki. Okay. So you found a flat earther online, and you're quoting him about this experiment. Is what's going on here, and that's where we get back into the self-referential thing. Do you know what Sagnac's conclusion to his own experiment was regarding, and did he say anything about the ether?
Okay, well, I'll give you the formal book where it's written. But what I said is they don't debunk Sagnet's experiment. They're just saying it's the same as an unproven Einstein theory, which is actually nonsense, because there's an observable observation. It has been done. The test is there. What does Einstein do? He disregards the ether. And how does he do it? By no experiment. By no experiment. So I can't see how you can justify it.
All right, so are you aware of the differences in the structure between the Sagnac experiment and the Michelson-Morley experiment and why they were configured differently?
Yes, because Michelson didn't do it on a rotation. He didn't interfere with the light, with the light, optical light experiment. But once we interfered, like you say, we have to interfere because we're a spinning ball. We discovered ether.
Okay, so again, I think you're inserting an interpretation of ether into the Sagnac experiment, which was not necessarily the case. You don't have the scientific background to understand what was going on with Sagnac, frankly, and I don't have time to explain it because it's a cross-examination time. So I'm going to move on to the next question about, again, well, let's talk about Foucault's pendulum then. What is your explanation as to why, when you push Foucault's pendulum in one particular plane and then don't interfere with it and give it any other lateral pushes, it changes from swinging in that particular plane over time? You can see it start to rotate. What's the reasoning for that?
Okay, if I push it like beep, with my pinky, will it do it? Will it rotate? Or do I have to use force?
So usually the way the Foucault
What will happen if I push it in one direction and push it hard in the other direction? Does the pendulum swing independently without interference?
So yes, it does. So usually the way a Foucault pendulum is started is they suspend it, and then they use a rope to hold it static in place in a location where it's got potential energy, and then they literally burn the rope so that there's no biasing in any particular direction, and it falls straight across and is in a particular plane with no bias in one direction or the other. And then over time, it does rotate. This is something that's been experimented with on multiple occasions in multiple locations, so it's pretty established.
You still conjuring the experiment.
No, I'm not conjuring it. I'm describing it.
What if I do this? What if it's still not proved? Because where's your independent variable here?
Where's your independent variable? Do you know what that even is?
You push it as well.
Are you repeating the words?
No, you still need to push it. There's no way around it. You still need to exert force on it. It's not moving freely. It's not a freely moving object. It's not a plane. It's not a plane. If that was true, then the plane from there from Carolina to Los Angeles would have been 1.5 hours, and that is not the effect. So you say that is proof, but the plane flying 3 hours longer is not proof. I don't think so. That's just somehow ridiculous. Sorry about it.
Okay, so we've already pretty well established that you don't understand how airplanes work. But I think what we need to do is we need to talk about the Foucault pendulum, which you seem to want to run away from very quickly. So what's happening with the Foucault pendulum, no one can hear you, so I appreciate that. What's happening with the Foucault pendulum is that as it swings, there's nothing touching it, right? It's going back and forth. Nothing is biasing it in any one particular direction. And yet over time, a rotation is observed. And that's what I need you to explain without ranting about airplanes.
Middle, and swings until it's finished. That's it. That's the observation.
That's not what that is not the observation.
No, the outcome of your experiment here is conjured with with which way you want to push it and how much force you want to push it with. That's it.
No, it's not.
That's how. That's the pendulum. That's how the pendulum.
Correct.
It's a circus sideshow. It's a circus sideshow. That's all I can say. What if I push it into the middle? Now the pendulum, I'm pushing it into the middle of the swing. It doesn't rotate. I'm just pushing it in the middle, and it's swinging back and forth. Now that's also now. What's that? Auto rotation. because I swing something, we have rotation. I don't think so.
Right. So let me ask you a question. What is the most advanced science course that you've ever taken?
None, but you know what? You don't need advanced science to observe
But you
natural phenomena. You don't need. I don't need to be a scientist to go at a dam and see still water lying flat. I don't need to be a scientist to do that. Okay, I can observe it, and that's what science is about. It's observing. It's observing, making a hypothesis, and then testing it. It's not observing, making an assumption, and making a mathematical formula to prove the assumption. That's not what science is. You need to go and do the scientific method. That's what science is. I don't need to be a scientist, but I know what it needs to be a scientist.
All right, fellas, that's 10 minutes right there. That's 10 minutes right there. That concludes the cross-examination portion of this debate. All right, so now we're going to transition to closing statements. All right, Mr. Pienaar, if you want to go ahead and give a closing statement.
I just actually want to thank Jonathan. He's actually a good guy. It's a sorry about his beliefs and stuff like that. But that's the thing about science. Okay, people say, like he said in his last question. Are you a scientist? What? That doesn't matter. This is observable facts. Flat Earth is observable facts. You can do it. There's no excuses. We've got a container. It's a firmament. You need that container to keep the gas in. We can observe lakes lying flat. You can see it for yourself. You can, from any angle, the water's gonna lie flat. You can't have flat spots on a globe. You cannot have the Suez Canal hundreds of miles parallel, flat, lying flat on a ball. It's just simple, natural logic. The thing is, we've been taught cartoon science, pseudoscience, something that's presented as science. We all think, hey, it's been proven. Gas pressure next to a vacuum hasn't been proven. Water curving around, conforming around a ball while spinning hasn't been proven. That's not natural. That's not even scientific. They want to talk about scientific things. Let's go to the scientific method and science. Not theory, not assumptions, not mathematical equations. Real science, observable science, testable science, repeatable science. That's what science is all about. If we're going to take every cartoon that NASA gives us well, I don't need to prove science. I've got a NASA cartoon. Yeah, admit it. And it's blatantly in your face. NASA gives you NASA cartoons. They say composites of paintings, images, CGI. Nothing from space is authentically photographed. We believe space because we were programmed from 2 years old to we're watching cartoons of space and aliens, but we haven't even come out of the container yet. And it's like I said, the ball Earth rotation is against every law of natural phenomena, the properties of matter, what we can observe. If we can't observe, if we can't make up stuff and give a mathematical equation to validate it, because it's still a made up stuff. We can conjure the numbers, we can do anything. I can say, hey, I think there's a unicorn. Let's make a mathematical formula, and therefore there is a unicorn. We can't do that because we haven't observed the unicorn. Thanks a lot for your time, Marlon. You're great. I know if some of the audio and videos were sketchy. Jonathan, thanks a lot. You are a good guy, and I would like to speak to you more, and that's why I friended you. Great stuff, man.
All right, thank you for the closing words. Appreciate you, Ms. Pienaar. All right, Jonathan, you got it for a closing statement for 10 minutes.
All right, very good. Yeah, I just thank you, Etienne, for going through this with me, and I appreciate you taking the time to do this. It's not easy to be, on camera and presenting your views and all of that, and so I appreciate you stepping up to the challenge. I wanted to really kind of drop all the arguments. Every point that I had to make has been thoroughly made. What I really want to do is I want to take this time to really address the issues of truth and how science works and how it fits into my worldview as a Christian, because I think this is really important. I have a very strong science background, and while I agree you don't necessarily have to have a strong science background in order to do observations, when you're talking about the scientific method over and over and over again, Etienne probably has never taken a physics course. He said he'd never taken a physics course. The reason why I asked that is because I'm curious if he's ever actually even been in a lab before. We don't go in there to be indoctrinated with mythical formulas about something. We're given sensors, we're given apparatus, and we're told to come up with our own formulas. And we're guided in doing that, but they come directly from experimentation. That's how science has always been done, and science classes walk you through that process. So a lot of the formulas that I use to explain things like why the spinning ball thing isn't nearly as much of a problem as flat earthers make it was something that I actually derived myself by literally taking a sensor and spinning it around in a physics lab. So these aren't just made up fictional formulas. They're formulas that you derive by doing things in the real world. And because God is a God of order, and God has created our universe according to rules, we can use math, which is a very ordered system of logic and reason, to model the world that God has created. And so it's very important to be able to see all truth as truth, and mathematical truth is just as true as spiritual truth. That doesn't mean that scientific experimentation somehow trumps what Scripture says, but we already addressed what Scripture has to say on this issue in the last debate. But when you really put the two together, they should complement each other. They should not contradict each other. And you shouldn't have to look at a picture and then say things that don't make sense. If you see a picture of a ship where the bottom of that ship has dropped below the waterline, And you can go online and see YouTube videos of people looking at an airport at a long distance and see an airplane coming in, and then here's the horizon, and it just drops right underneath the horizon as it lands. Observations like that are made, and when you present them to a flat earther, they just start saying things about, perspective, something you can't see to China. But it's like, well, I can see half of that ship very well, and the other half I can't. So perspective seems to be this magic buzzword that somehow makes the problems go away. When you see a picture that shows evidence that you're wrong, you just like, scrub. We're going to use these words. We're going to make it disappear. That's not how truth works, my friends. That is not how truth works. And for those that are flat earthers that are listening to this debate, I hope you can at least recognize who was coming with observations and evidence and who actually was able to back up what they were saying with specific experimental evidence, rather than just repeating what you guys have heard over and over on YouTube. The flat earth community, which I have taken the time to listen to what you guys are presenting. I've watched every video that Etienne has linked to me, even though they're hours and hours long, about gas pressure and so on and so forth. You guys are kind of an echo chamber. You listen to yourselves. You all use the exact same arguments. You've all been brainwashed by this idea that there's never been any evidence. I don't know how many times Etienne said during this debate, there's no proof of a globe. It's never been observed. There's never been any evidence. He's saying that because that's what he's been told over and over and over and over again. And yet when I present the evidence of curvature, when I present the evidence of motion, he just says, well, that experiment's fake. So what you've done is you've cut off all evidence of the globe, and then you justify your belief by saying there's no evidence of a globe. That is how the flat earth movement gains its steam. It just repeats over and over, there's no evidence. And then when you present the evidence, it just says, well, I'm not going to accept that evidence. There's no evidence. That is not the scientific method. Etienne even said, you can't just come up with a theory and then just come up with evidence that supports your theory and just make it all up. You have to observe, repeat, and examine these things. Nobody has observed a flat earth. The fact that you don't understand how curvature works and you don't understand how distance works doesn't mean that you can't observe the curvature. Whenever you see those images, you just blank them out, or you just come up with some explanation about perspective or something that really doesn't have any justification behind it. It's just a way of whitewashing the truth so that you don't have to deal with it. And that's concerning because that's not a Christian approach to life. Jesus said, I'm the way, the truth, and the life. I believe all truth is God's truth. And that's why I love studying physics. And whatever science you happen to get into, whether you study physics or chemistry or biology, the Bible says the heavens declare the glory of God. There's absolutely nothing about genuine scientific observation that we as Christians need to be afraid of. There should not be a Christian flat earth community that militates against the religion of scientism, as if science itself, as if the practice of observing our world somehow militated against the very God that created that world in the first place. Science and reason and logic can only be done in a Christian worldview, and those scientists that are atheists are forever borrowing from our worldview to even do science in the first place. And so I really hope that any Christian who loves Jesus and yet who has been taken in by this flat earth nonsense will hear the differences between how flat earthers approach this subject and how a Christian believing person that also understands science approaches this subject, and we'll see that truth is consistent. The Bible and science do not contradict each other, not even a little bit. And we need to be consistent in how we're dealing with the truth. In closing, I would just like to, again, run down some of the evidences. In dealing with the idea of rotation, the Sagnac effect versus the Michelson-Morley experiment and the ether and all of that. Again, the ether has been proved not to exist. Michelson-Morley was designed to prove that the ether exists and to observe it, and yet they came up null. There is no ether. It's not been proven. And so again, understanding the science there, though, is very complicated. Optical physics is not simple. And frankly, to have someone that has never taken a physics course and has never done experiments with light in a laboratory like I have, trying to explain the Sagnac effect is really, again, inconsistent. It doesn't work. Finally, in dealing with the messaging of the atmosphere and the vacuum, we hear over and over again how, well, you can't have tire pressure without a tire, as if there's this extremely high pressure system and then immediately outside of it, there's nothing. And somehow that high pressure system magically fits. And even though I explained multiple times that it isn't just super high pressure right next to very low pressure, he could not bring himself to step away from that talking point. And again, that's the flat earth strategy. You get an argument in your head, and even when it's proven that that argument does not fit the model you're critiquing, it has nothing to do with the discussion. And the thing that you're reading is in the context of a laboratory and not in the outdoors, he will continue and continue with the same argument because he learned it off YouTube, and that's the only argument they have, guys. I listened to 2 hours of a video, and it's literally all that exact same argument, and it has nothing to do with the reality of the situation. So again, I would just say, as I am out of time, you really have got to learn both sides of this discussion. Flat earthers, you've got to stop listening to flat earthers. Start listening to some other people. Challenge yourself to actually deal with the evidence that's out there. Seek truth and stop being brainwashed. You can do better. I believe that you can. All that love truth and love the God of truth should do better.
All right, if you heard that, that's time, Jonathan. That's time, man. All
Right in there.
Right in there, right on time, brother. Right on time, man. All right, fellas. Thank you guys for coming on. It's a scary thing when you put your position in the open internet. YouTube is wide open, man. So
I was jittery, man. This is my first time stuff. So yeah.
I totally get it, man. My first debate was in October, and I got some people encouraged me, and some people drug me through the mud, man. So you're gonna get flack from both directions. But I appreciate both of you taking that courage and putting yourself out there for everyone to see. And as always with my guests, I like to send out gifts. Even to South Africa, I send gifts. I sent them to UK, and I think I sent one to UK, and I think Nigeria. So, yes, the gift will get to you. So, I will be sending you gifts. I'll be contacting you to get gifts to you guys. So, thank you once again, and I appreciate all the effort you guys put forth in preparation for this. And, may God bless you. May God keep you.
Can I interrupt you?
Go ahead.
Just a little. Can I actually have a debate with Jonathan on the biblical thing?
Oh, I think we can schedule that. I think Jonathan's open to it. We can talk about it more after this.
Yeah, let's do it on 6 months' time or something like that. It's just not. Yeah, let's rush it.
Okay.
Just no Nephilim and demonology on this one. All right.
No. We'll go through real text. Yeah.
I'd be more than happy to do that, man. It's
I think what Brennan wanted to do was trying to tell people why they lie. But I'm just gonna say I'm gonna keep it to the real stuff like today. If Jonathan wants.
Tell you what, man, whether we do it on here on the Gospel Truth or not, I'd be happy to talk through verses with you, online or offline, in a public debate or in private with just you and me, all right? Either way, I love getting into the scripture.
Great, but yeah, well, what does Marlon say here?
Yeah, I mean, I mean, obviously, if you guys want to have a solo conversation, I'm all for it. Obviously, that's independent of me. But if you guys want to jump on here, I can definitely schedule that out. So we'll talk more about it after the show's over. So, um, thank you guys, and I appreciate you so much.
All right, thanks a
Thanks
lot.
a lot.
All right, all right. That's another one. See, we connected the the two bookends there, right? We got the biblical side and we got the scientific side, and we got all this information mushed between those two bookends, right? So it's good stuff, man. And I'm glad that Jonathan was able to do both of them, and Mr. Vernon and Mr. I'm gonna go for it. I'm gonna try not to destroy your name. I'm gonna go for it. Etienne. Is that right? Etienne? I think I got it right. Oh man, I hope I got it right. But if I didn't get it right, man, please forgive me. That's not my intention to jack your name up. But yeah, I'm glad for both of those guys to come on, and Jonathan be able to come on and debate both of them, so we can get the information out. And you know, it's so important that we, as Christians, that we don't just ponder on what fits our thoughts and fits our positions. Let's challenge ourselves. Let's get out there and let's look at the other content and those opposing arguments and see how you deal with those arguments. If you can deal with those arguments on a consistent level, when we're dealing with the Bible and, we got the old Calvinist Arminian debate, when you're taking arguments from the Arminian position, let's see if we can deal with those in a consistent, hermeneutical, properly exegetic position. Then that's how you argue those against that. Same thing with scientific evidence for flat earth and biblical evidence for flat earth. Take those opposing positions, wrestle with them, and if you could come to a consistent, proper, logical conclusion that your argument and your position is right, then you've won. But if not, then you have to be able to say, you know what, you have to humble yourself and be like, well, this is not consistent, and you might have to let some of that position go. But that's how Christians should deal with it. Remember, we're not just arguing we're not just conversing amongst ourselves. We're putting ourselves in the open for atheists to see. Those who don't believe in Christianity, don't believe in Christ. So when we argue in a position that's not consistent, then we're letting the world know that Christians are not consistent. And that's not how we want to represent. We want to represent Christ in a manner that's glorifying to him. And God can use any tool, even a debate like this, to draw those to himself. So we want to make sure that we're doing it correctly and we're doing it with God at the forefront of all that we do. All right? But with that said, I can't leave you without preaching the gospel to you. Jesus Christ bled and died on the cross of Calvary, was buried for 3 days, resurrected all power in his hands, and he died to alleviate the wrath that God has on all sinners. God has died and atoned for the death of those who he called before the foundations of the world, his elected people. So if you don't believe that, I earnestly and I plead with you to believe it. It's vitally important that you put your faith in Christ, because Christ is the Messiah, he is the anointed one, and he died for the sins of this world, and he called his people out of sin. So I pray that God has drawn you out of your sin, and I pray that you receive him as your Lord and Savior. With that said, before I go, let me go ahead and hash over these announcements. Coming up in a couple days, I have the last show of this year. I have a debate between Travis Worth and Solomon Rodriguez, a Trinitarian Unitarian debate, and they're going to be debating the nature of Jesus. How should Hebrews 1:3 be interpreted? And that's coming up December 30th at 6 p.m. Pacific Standard Time. And my first show of the new year, it'll be actually January 4th. Have Pastor Andrew Rappaport coming on. We're going to be talking about some systematic theology in his book, What Do We Believe? And coming up after that, January 6th, I have another debate. Do Atheists Have Faith? That's going to be Christopher Lee and Joshua Dogle. And they're going to debate that. Do Atheists Have Faith? And it's going to be January 6th, 2020 at 6 p.m. Pacific Standard Time. And we have a big one coming up, Mr. Matt Slick versus Sonny Hernandez, theological determinism versus compatibilism. And this debate is going to be, does the Bible teach free will? All right, and that's coming up January 27th, 2020 at 6 p.m. Pacific Standard Time. Once again, this is not the last couple of debates. This is not the last show that I have coming up. I have a whole bunch of shows coming up. So if you want to be up to par and want to get all the updates, notifications of what's coming up, go ahead and like and follow on Facebook, and go ahead and cut the notification bell on, and do the same over at YouTube. Subscribe and cut the notification bell on. And also, don't forget, for all you who do not have time to sit down and watch a debate on TV or YouTube or whatever, I have all this content on iTunes, podcasts, Google Play, Stitcher, Spotify, all those platforms for podcasts. So go ahead and subscribe there and be in the loop with all the upcoming events and shows. So with that said, I'm going to get on out of here and enjoy the rest of my day. Once again, I want to thank Etienne, Pienaar, and Jonathan Walters for coming on and debating this hot topic. And I appreciate both of them. And may God bless you, and may God keep you, and be on the lookout for all the upcoming shows. God bless you.